Okay, so our 2022 ExamCraft mock paper 1 question 6 is all about our calculus stuff. Okay, so it says the curve C has equation and it gives us our equation. It's worth noting here, this is the second short question in section A that has calculus in it. Okay, so this is an example of why we can't just leave out any one topic. Okay, if you decided, oh, I'm going to try and leave out calculus, already we're seeing here that even if you looked at 5 of the questions and you left this one out, okay, you can't dodge calculus. Okay, it really could be the same with any of the other topics. Okay, they could go across any amount of questions that they want to. Okay, so even though you're going to have a choice on your paper in 2024, or in this year it was 2022, it doesn't allow you to just fully avoid any one topic. Okay, this question gives us an equation in y, and it wants the first derivative. Okay, so dy dx we know is the first derivative. So what I'm always going to do before I go and write down what the first derivative is directly on top of it, I am going to rewrite the equation. Okay, this means that if I get anything slightly wrong when I'm looking up at this equation, that I make my mistake here while I'm taking it down, and the examiner might see, oh, I've taken it down wrong, but I still got the first derivative correct from what I was seeing this as. Whereas if I was trying to jump from up here and then re-looking up and down, it sounds like a very simple thing, but on the day of the exam, when there is a lot going on, it is an opportunity for you to make silly mistakes with things like signs being incorrect and stuff like that. Okay, so it is worth just starting by writing down the equation and then saying, okay, so what is dy dx? And now, because I have it directly above, I can literally focus in on, okay, just this term, and directly below, what am I doing? This term directly below it, and so on. Okay, so remember how we get our first derivative. Okay, we look at our original equation, we multiply by the power and reduce the power by 1. Okay, so here my power is 3, so I multiply by 3 and I reduce the power by 1. Okay, now I'm on to my next one, minus 11x squared, so I multiply by that power, so I get minus 22. Okay, and then I have an x, and the power is then reduced by 1. Okay, so when that power is reduced by 1, it's a power of 1, which I know I don't need to write. Okay, this next one then, plus 35x. Now, this is one of our rules, and we went through the reasoning behind this in class, and probably in previous videos as well. If in the original there is no power on the x, that means that in the derivative, it's just the number from in front, okay, and the x is going to disappear. We went through the idea behind this in class a good bit, okay, so that's just going to go down as 35 without the x. And likewise, if in the original there is a number and no x involved in it, in the derivative of this, it just disappears. It's just nothing, or it's just 0. Okay, so this here is my first derivative, and that's it. Okay, so it's a nice question for 5 marks. And the second question is quite nice as well. It asks for my second derivative. Okay, so again, what I'm going to do to start this is I'm going to write down, well, what was my answer from the last part? Okay, this way, if I made a mistake in the last part, the examiner can clearly see what I'm starting with, as if this is my first derivative. And I can still get full marks then for getting the derivative of this, even if there was a mistake up here. Okay, so I want to start by writing down what I am thinking is the first derivative, and then I need to get the second derivative. Okay, so remember how we get the second derivative? Okay, d2y dx squared. How we get that is we just treat the first derivative as if it's the original and get the derivative of it. Okay, so treat basically this as if it's y, and then you're just getting dy dx. Okay, you're literally just getting the derivative of the derivative. So start going through it again, okay, multiplying by the power and reducing the power by 1. So 3x squared, so the 3 multiplies by 2 so that I get 6. Okay, then I have x, and I can write down a power of 1, or I can leave it not there because that's my invisible maths. Okay, here then I have minus 22x, and this x doesn't have a power on it in my original. So in the derivative, it just disappears, but the number in front stays. Okay, so minus 22, and then the x is gone. Okay, and likewise here in the original, I have a constant. Okay, it doesn't have x's involved with it, which means in the derivative, it's not there. Okay, so this here is my second derivative. Okay, it's my second derivative because it's the derivative of the derivative. Okay, so that's my first page there of question 6. Then the question goes on and it says, verify that C has a stationary point at x is equal to 5. So a stationary point, what is a stationary point? Okay, now if we go up to, actually I'm not even going to look at the shape of a cubic. Okay, a stationary point is a turning point. Okay, so remember our stationary points, they are our turning points. Okay, how do we know my values of my turning points? Or how do I get those? Okay, I get those by saying when is the slope 0? Okay, so when is the slope 0? So remember my slope is my first derivative. Okay, and I'm saying when is it equal to 0? Okay, those are my turning points when it's equal to 0. Okay, so if I look at this curve here, I have a turn here and here. And if I look at the slope at those exact points, okay, it's a slope of 0 at the turning point here and a slope of 0 at the turning point there. Okay, so that's what I'm looking at. Okay, I have 2 different ways of doing this. I can go and find my 2 turning points. Or I can say, okay, well, what is the slope at x is 5? Okay, if the slope at x is 5 is 0, then I know it's a turning point or a stationary point. Okay, so earlier on, I found dy dx. Okay, so I'm going to write it here as f dash of x, just so that I can fill in what x is going to be. Okay, so this is another way that I can write my first derivative, f dash of x. Okay, the same way, the same thing as dy dx. Okay, so the equation there was 3x squared minus 22x plus 35. Oops, trying to zoom in here. Okay, so I could see there, what is the slope at x is 5. Okay, if I sub in 5 there, I am getting the slope at x is 5. If the slope is 0, then it's a stationary point. Okay, so that's going to give me 3 by 5 squared minus 22 times 5 plus 35. Okay, so 3 by 25 is 75. Oops, here we go. No. 75. Okay, then here minus 110 plus 35. Okay, so I see that it is 0. Okay, so f dash of 5 is equal to 0. Okay, so therefore it is a stationary point. Okay, so therefore x equals 5 is a stationary point. That's one way of doing it. Okay, but the other way of doing it is the way that basically if they say find the stationary points and they don't give us that possible answer. Okay, so here they say verify. So there is a very important difference in our wording here. Verify means that we can sub it in from the start. Okay, so when it says verify, It means from the start, you can sub in. Oops. Okay, so verify from the start, you're able to sub that in. Okay, if they said something like show, it means you have to pretend that you do not have the answer that it's x equals 5. Okay, so if they said show, then it means that get the stationary points and get an answer of 5. Okay, so if they just said show that a stationary point is x equals 5, it's a very different question. Okay, so we need to look at this and say, okay, what are our stationary points? Okay, so our stationary points are when the derivative is equal to 0. Okay, so I'm literally doing this out again here. Okay, as a way that was probably more likely that you saw, because it's a way that we've done it in class multiple times. Okay, we're going to let f dash of x equal to 0. So that means that I have 3x squared minus 22x plus 35, and I have to let that equal to 0, and I have to say, okay, what are my values of x? Okay, because it's a cubic, I am going to have 2 turning points, okay, like I have up here, which means I am going to get 2 answers for x here. Okay, I have 2 turning points. 5 is just going to be one of my answers for x. Okay, so go and solve here for x. We can use our minus b formula, or we can factorize and solve. Okay, if we're factorizing this, the number in front of the x squared is not 1, which means it's a slightly longer method of factorizing. I need to say, okay, 3 times what gets me to, 3 times 35, and that's what my guide number is. Okay, so 3 times 35, so that my guide number is 105. Okay, so I'm going to list out my factor pairs for 105 and see which of those add to give me a minus 22. Okay, so a plus 105, which means the signs have to be the same. Okay, so when I'm listing out my factor pairs for this, I want the signs to be the same. I could use something like, let's say, 15 and 7. Let me just check. 105 divided by 15. Yeah, 7. Okay, now they have the same signs at the moment, but are they going to add to minus 22? No. Okay, they're going to add to minus 22 if I put minuses in front. Okay, they still both have the same sign, so they still are multiplying to give me a positive. Okay, and I can move on to my next line of solving this quadratic. Okay, so how do I continue on solving this quadratic? I'm going to rewrite it out. So I have a 3x squared, and I'm going to rewrite the exact same equation, but see this minus 22x? I'm going to change that for a minus 15x minus 7x. Okay, so I'm not changing anything about the equation here. Okay, and I'm writing down the x's as well. I'm literally changing out minus 22x with something that it's equal to. Okay, and then I'm copying the rest of the equation down. And then at this point here, this mock actually had a lot of these quadratics. I think this is the third one that it's had where the number in front of the x squared is not 1, and it's this longer method. So it definitely, if you haven't gone over these, it would be a bit mean of a mock. Okay, once we've gotten this out like this, okay, then I can factorize it and solve. Okay, when you're factorizing something with 4 terms like we have here, we use a grouping method. So we group the first 2 together that I've underlined there, and we factorize them using our highest common factor method. Okay, so what is my highest common factor here of 3x squared and a minus 15x? So what's in common with the 3 and the minus 15? There's a 3 in common there. And what's the highest thing in common between an x squared and an x? There's an x in common. Okay, so I take out what's in common, and then I say to myself, what does that need to multiply by to get me back up to what was up here? Okay, so 3x times what gives me 3x squared? It's an x. And 3x times what gives me minus 15x? It's a minus 5. Okay, so that is me having used the highest common factor method with the first two terms. And then I'm going to do the highest common factor method again with the last two terms. So last two terms, I'm just going to get a different colour here. Okay, the sign that we take out of these last two terms is almost always that middle sign there. Okay, so I'm going to start here by just taking out a minus or writing down a minus and then saying, okay, what does a 7x and a 35 have in common? Okay, and they have a 7 in common. So I'm going to take out a 7 and I'm going to open up brackets and I'm going to say, okay, what does minus 7 have to multiply by to give me a minus 7x? It has to multiply by an x. And what does minus 7 have to multiply by to get me to plus 35? So a minus by what gives me a plus? It's a minus. And 7 by what gives me 35? It's a 5. Okay. Then the next step in this, so these are just steps that we learned off in junior cert and then again when we done algebra in 5th year. Okay, my next step for this is to open up two brackets, put what was outside the two brackets in one bracket together. Okay, so my 3x and my minus 7. And then put what was common to the two brackets in the other bracket together. So my x minus 5. Okay, so now I have two brackets that are multiplying together to give me 0. So I let each bracket equal to 0. So I'm going to have 3x minus 7 is 0. And I'm going to have x minus 5 is 0. Okay, so here, if I want to solve for x, I have to add 7 to both sides. So I get 3x is 7. So x is 7 divided by 3. And here, to get x on a side by itself, I need to add 5 to both sides. So now I have my two values of x that are turning points. Okay, so I can now finish my question by saying, therefore, stationary points or turning points or whatever. So stationary points at x equals 5. Okay, I don't even need to mention the other one, but just if it did ask. And x. This is getting a bit messy here. Let me just. So, and x is 7 over 3. Okay, the question then says, is this stationary point a maximum or a minimum point? The way that we done this out in class, because we didn't do it by introducing second derivatives or anything. Okay, what we're going to do is we're going to find the matching y coordinates to each of my turning points. Okay, one of these is a max and one is a min. They're both turning points. One of them is the maximum turning point. Okay, look up here. One of them is a max turning point and one is a min turning point. Okay, so we need to figure out which one is which. Okay, so to do that, we're going to find their matching y coordinates. Okay, so go back. How do we get a matching y coordinate? Remember what all my different types of equations show. Okay, so the original equation, okay, gives me the y coordinate. The first derivative, so f dash of x, is giving me the slope. Okay, so I've just found where is the slope 0. And then f dash of x is the behavior of the slope. Okay, so it might come into play if, let's say, we were looking at distance and speed. Okay, the behavior of how the speed changes is the second derivative. Okay, so the acceleration. Okay, so the change in slope, or in our things, if it was distance, speed, time, it would be our acceleration. Okay, so change in slope. So here, if I want the matching y coordinates for each of these, which of the types of equations do I use? I use the original. Okay, so my original equation, I have to go back to get it. So go back to part A here. Okay, y is x cubed minus 11x squared plus 35x minus 25. Okay, so I'm going to start by writing that down. Okay, so y is equal to, so x cubed minus 11x squared plus 35x minus 25. So I am going to work out my y values for both of these turning points, and I'll see which ones is 5 the higher or the lower of the two. Okay, so y when it's x is 5. Okay, so that's the first one I'll do. So x being 5. Okay, so y is 5 cubed minus 11 times 5 squared. Do I know what 5 squared is off the top of my head? Yes, it's 25, but I am showing my subbing in before I do anything else. Okay, plus 35 by 5 minus 25. Okay, so put all that into your calculator. Okay, so 5 cubed minus 11 times 5 squared. Oops, I'm putting all that into my power because I never went back out of my power. So 5 cubed minus 11 times 5 squared plus 35 times 5 minus 25. Okay, and we're getting 0. So that is equal to 0. Okay, and then let's do it again at x is the other one that I got, 7/3. Okay, so I've literally just typed this into my calculator with 5 in brackets everywhere, which is super handy for me when I'm subbing this in the next one, because I can just delete 5 from all the brackets and put in 7/3 everywhere that I get rid of the 5. Okay, so 7/3 to be squared plus 35 times 7/3 minus 25 is equal to, okay, so I'm going to go back through this, okay, and put in 7/3 in those 3 spots. Seven over 3. Okay, and for this one, I get a mad answer. Okay, 9.48, blah, 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 blah. Okay, so is at x is 5, is this the lower or the higher point? Okay, it's the lower point. It's at a lower y coordinate. Okay, so if you think about those two y coordinates on your graph, okay, we have 9.48 up here and then 0 all the way down here. Okay, so this is the minimum. Okay, it's a lower y coordinate. So x equals 5. Is x equals 5 that they were talking about in the question above? Is it a max or a min? It is the min. Okay, justification, we have shown there that it is a lower y value. Okay, we will also write that in words just to make sure. Let's see. X equals 5 has a lower y coordinate than the other stationary point. or turning point. And that's it. Okay? So that was kind of a mean question, but it was also stuff that we know and we've seen before. It was nothing that we haven't seen before. So in that sense, it was quite nice.